All right, so table of contents today, we're gonna walk through smart contracts. What is it? What's Ethereum? Walk through EVMs, and then some use cases that in Ethereum, using Ethereum. All right, so let's start off with smart contracts. But before that, let's have a review question. This goes back to lecture 1 or 2, and let's talk about what makes Bitcoin so special. Actually, I'll take any, comments if you remember some answers on this extra point, if any. Does anyone
like a finite supply?
Okay. Anything else? That was good. Thank you, Daniel. All right. Well, to answer that, so 1 second. So what makes Bitcoin so special is that Bitcoin has 4 key components. It has 1, identity, 2, record keeping, 3, transaction, and 4thly, consensus. And these 4 main components was what differed Bitcoin from everything else at the time. But mostly it's a distributed network. So let's just dive into the specifics. So first, it's pseudonymous. If you remember, when we talk about Bitcoin, we emphasize the importance of identity, especially in order to enable authentication and integrity. So we have cryptographic identities that allow for accountability, which gives everyone a unique identity through a hash, if you remember. And this generates a private key and also a public key. 2, it's democratic. Decisions are made through a consensus protocol. If you remember, it's proof of work that is being used in Bitcoin. So it doesn't require you to trust anyone on the network, and you just need to trust the math behind the consensus. Thirdly, it's immutable. Everyone's used the same version of truth since we have consensus. And that means it's also tamper evident data structure so that no one can change the history. And what we do is use the Merkle tree structure to compare the hashes in order to see it. 4thly, it's uncensorable. To censor transactions, you need to own 51% of the network, which we talked about is pretty hard, and you wouldn't really want to do it because you won't profit a lot or at all. And so it cannot be controlled by any one party. 5thly, it's distributed. So that means there's no central point of failure. And the execution of transactions on the network depends on the network of miners located around the world. So as we talk about Ethereum, please just keep in mind of Bitcoin's architecture. All right, so since we're talking about smart contracts, let's just all agree on what traditional contracts mean. So a traditional contract must be agreed upon and enforced by law. Thus, we need a consensus protocol. And through a consensus, we should be able to agree on both the contents of the contract and the execution of the contract, right? So what makes a smart contract smart? So a smart contract is basically a piece of code that facilitates, verifies, or enforces the negotiation or execution of a digital contract. So in order to reach consensus, trusted entities must run this code. And we all need to trust that this digital contract is enforced correctly. So the difference from a traditional contract and a smart contract is the execution and enforcement is done through algorithms and not through law. All right, so we're moving on to Ethereum. So has anyone heard of Ethereum before or kind of know what it is? Just give me a thumbs up if you have heard of it. Yeah, Nate, I hope so. Okay, cool. So what is Ethereum? On its website, it says Ethereum is a decentralized platform designed to run smart contracts. So basically, it's a distributed computer spread amongst a multitude of nodes across the world that executes code that people feed into it. And because of this specific architecture, it can run many applications. And the execution of transactions basically bring us from a previous state to a new state. And that's called a state transition function. And we all heard of Ether before, mostly if you're into cryptocurrency. Ether is Ethereum's native asset. It's basically the value in Ethereum ecosystem. And it's not because of investment or anything, but it's crucial in aligning incentives in Ethereum. bonus points for anyone who can name, that's me and some guy. Do you know who that guy is?
Vitalik.
Yes, Daniel. Yes, this is Vitalik. I was super excited to meet him at a blockchain conference in SF. So it was great to just see him talk about plasma and all his new research. So that was really cool. So yes, that's Vitalik, the founder of Ethereum. Cool. So this is just some miscellaneous implementation details. So from block creation time, Bitcoin actually takes 10 minutes for a block to be created, whereas Ethereum takes 13 seconds, which is a huge difference. And the exchange rate, when I was actually writing this recently, I was really sad because the last time I wrote this was in October of last year, and the price was 367 USD for 1 Ether. But now it's 1,788 USD. So I'm pretty sad that I didn't get it earlier, but you can see how kind of increasing it is right now. Okay, cool. So what is the difference between Bitcoin and Ethereum? Let's do like a side-by-side comparison. So like we mentioned a few slides before, we know that Bitcoin is special because of the following. It's the first successful cryptocurrency. It's trustless, it's immutable, it's uncensorable, it's pseudonymous, there's no central point of failure, it's one CPU, one vote through proof of work. But Ethereum has all of these values, but has a different use case. So here's the difference. Ethereum and Bitcoin are actually, the two most popular blockchain platforms with two different goals. So this is just like walk step by step. So Bitcoin, you might have heard that it's, the gold standard of blockchains, and the asset is Bitcoin. It's, it's been around for the longest and has successfully supported many number of transactions. It's simple and robust. It's UTXO based. If you don't remember, UTXO based is like, the piggy bank analogy. Hopefully you remember that. And it's also not Turing complete, meaning it can't have a loop. And the main purpose of Bitcoin is to allow transactions of Bitcoins, right? All right, but how about Ethereum? So Ethereum is a smart contract blockchain platform. It's to execute these contracts that are written, and it's seen as a distributed world computer. And the asset is Ether. It exists to fund computation and also align incentives. And the main purpose is not just a global payment system like Bitcoin, but it supports a little bit more features like running programs on Ethereum. For example, decentralized apps, dApps for short. And it uses a Turing complete, which means it's able to write a loop, which means it's more developer friendly and there's more applications that can be written. Okay, hopefully that's clear. So let's look a little bit into Ethereum accounts. So first, in Bitcoin accounts, we know that private keys are there to prove ownership of a UTXO, right? When you spend Bitcoin, you spend from the previous transactions. And to calculate the current balance, you have to sum up all your UTXO or all your piggy banks that you owned. And this makes it easy to make a transaction and prevents double spending, right? But in Ethereum, we don't use UTXO. We use private keys, which proves ownership of accounts and tracks a current balance. So this makes it more space efficient than UTXO, as when calculating your own balance, you just reference your own account, which is stored next to the address in the state. And you really only need access to your Ethereum wallet. So what this does is that it's much cheaper and it's easier to look up an account balance and transfers between accounts when we have an account model. Cool. So there's two types of Ethereum account models. First, it's the externally owned one, and second is the contract account one. So what's the externally owned account? The externally owned account is basically, it contains an address that they use to let people send them Ether, and also has a balance of Ether that they own. And it's owned by an external entity and sends transactions to transfer Ether or trigger contract code. Second, there's contract codes. It's owned by smart contracts. It contains an address associated with the contract and persistent storage. And the code is basically executed when externally owned contracts or other contract accounts make transactions to trigger the code's function calls. So it's basically just triggering the whatever code it is for the contract account. All right, so smart contracts are like autonomous agents that live inside of Ethereum network. You know, it reacts to the external world when they are basically poked by the transaction, which calls specific functions in the code. So it has direct control over first the internal ether balance, the internal contract state, and thirdly, the permanent storage. So just to wrap up this part, what are the main purposes of Ethereum or a smart contract? Like, what's the point? So one, it stores and maintains data. The data representing something useful to users of other contracts. For example, it could be a smart contract defining a new token currency or an organization's membership, which you have to pay a certain amount to obtain. Two, smart contracts can be used to manage a contract or relationship between untrusting users. For example, there's a lot of use cases of insurance companies maybe using smart contracts in the future for like rent and so on, or financial contracts, etc. Thirdly, it provides additional functionality to other contracts. So it writes contracts that calls other contracts, perhaps using them as a software library or leveraging the functionality of an existing contract. And fourth, smart contracts can be used for complex authentication use cases. And these use cases will be talked more about by Ayush later. Okay, so the recipe for mining. So first you gotta download the entire Ethereum blockchain. And then you have to verify incoming transactions and run smart contract code invoked by the transactions. And then you have to create a block and then find a valid nonce, which is because we use proof of work still. ETH2, however, is moving to proof of stake, which is probably more environmental friendly. And then you broadcast your block and then you basically profit. So in total, just to recap, Ethereum is a distributed computer. It uses or currently uses the consensus protocol of proof of work. And that's when miners competitively create blocks by executing code and searching for solution to the mining puzzle. You know, the network consensus removes the need for trusted third party, and there's secure peer-to-peer agreements that live on the blockchain forever. So hopefully that like kind of summarize Ethereum and smart contracts. And so we have a little pop quiz right now. Okay, well, I put the answers there, so maybe not really a pop quiz at the end of the day, but it's okay. So let's just walk through this. You know, what types of transaction model Ethereum uses? So it doesn't use UTXO-based system. Like we said, it uses an account-based system. It's a complex and feature-rich because it's not just, you know, transactions between like crypto or like value transactions of crypto, but it includes like applications, so on. And it is a smart contract blockchain platform, as we know. Cool. So let's move on to EVMs, which is short for Ethereum Virtual Machine. And it's basically like, you know, how Ethereum kind of runs or what it runs on. So Ethereum smart contracts are generally written in high-level programming languages. And some of you might be computer science majors, so you might have heard of these. So we have Solidity and Viper, which are the two most commonly used languages that write smart contracts on Ethereum. So the difference is Solidity is a mix between C++ and JavaScript, whereas Viper is more Python-like. So smart contracts are written in these language and basically compiled down to an EVM code, or you can think about it as a machine language. Thus, it translates from a human-readable language through a compiler to a simple language for a machine to understand and execute. And you can see this through the diagram right here. Cool. So a little high-level overview. Basically, miners in Ethereum creates blocks by executing the EVM code and search for a solution to a mining puzzle. And every Ethereum node runs, has to run EVM. Cool. So what if our contract has an infinite loop? So if there is an infinite loop, every node will be stuck executing the loop forever. And by the halting problem, if you learned in 70 or 170, it is impossible to determine ahead of time whether the contract will terminate, right? And this leads to an easy way for attackers to launch a DOS attack, which means denial of service. And the denial of service attack is basically trapping computers around the world in an infinite loop, which means it's unable to execute other meaningful contracts. So obviously the Ethereum founders thought about this, and that's why gas in Ethereum is a thing. It's the solution to this problem. So this gas is what fuels the execution of a given contract. It's what you have to pay the network in order for your transaction to go through. So you can think about transaction fees in Bitcoin equivalent to gas in Ethereum. So every EVM opcode requires gas in order to execute, which prevents infinite loops and any denial of service attacks. So every transaction specifies, one, the start gas, which is the maximum quantity of gas it is willing to consume, and two, the gas price, which is a fee in Ether the contract is willing to pay per unit gas. Okay, and every transaction has to have this. So let's just walk through this transaction and if it gets executed or not, and how gas comes into play. So at the start of the transaction, there's the start gas times the gas price, which basically represents the amount of Ether paid for a computation. So this is subtracted from the sender's account, the sender being the one who invokes the contract by sending this transaction. If the contract is successfully executed, the remaining gas is refunded to the sender, right? Because not all the gas has been used up. But if the contract execution runs out of gas before it finishes, the execution reverts, right? Because you don't have enough gas, so there's basically not enough power to keep going. So, but the Ether paid is not going to be refunded because although the contract execution gets reverted, someone on the network has put computational power to execute whatever EVM code you put. And once the gas is spent up, it proves that, that someone executed the program. Thus, it's not refunded. So there's two end states. One, you run out of gas, or two, the program just terminates. And even though Ethereum still allows someone to write an infinite loop, it's possible to do it. But the attackers attempting to DOS the network will have to pay enough Ether to fund this. And purchasing gas is, a price you have to pay to use this distributed computational power, and which costs a lot. If you check up gas fees right now, it's going to be high. So this disincentivizes users from running expensive computations without having sufficient funds. So it will cost attackers a large amount of Ether, which is basically not worth it. All right. So let's talk about state transition functions. So when we execute a transaction, we go from a previous state to a new state. At the beginning, there was just a blank genesis state, which means, it's like the first block. And then many transactions were executed after that. And any point in time, the final state represents the current state of the Ethereum blockchain. So at the start, you have the current block state, the gas required, current memory, etc. Basically everything you need to correctly execute a transaction. And you feed this into the EVM and get out the new block state with all the updated account balances and states and new gas value. And the gas that gets refunded too, if it's properly executed. Okay, an actual pop quiz questions without the answers. So, what do start gas and gas price refers to? Extra points for, just speaking out loud. It's okay if you get it wrong, Give you a minute to think about it. Okay, sorry, I don't see the chat. Okay, we got C, we got B. Oh my gosh, I'm confused now. B, okay, people are saying B. Okay. Can anyone just like speak out? I think. Okay. Well, B is correct. So the start gas is the maximum amount of gas the owner is willing to pay. And the gas price is the price of gas in Wei per unit. Wei is kind of like just a unit, right? It's equivalent to ETH in the way that a penny is equivalent to the dollar. It's basically the smallest denomination of the currency. Okay, thank you for everyone who participated. Cool. So conclusions. So the main goal is not to optimize computational efficiency, but enables distributed and trustless computation. Every node on the network has to run the same computations, which is basically redundantly parallel because they're doing all the same things on different computers. And the contract executions are, replicated across all nodes. The execution is very expensive. It is memory intensive. It is slow. So it is not supposed to be efficient. You have to know that. It's supposed to be a way for us to reach consensus among all parties and have a trustworthy output of the code. So here's a little comparison. Why would you use blockchain and when would you use a centralized database? You don't have to use blockchain for everything as much as the news tells you. So use blockchain when you need for a shared database with multiple writers, mostly with parties you cannot trust, and when there's no trusted third party or authority that is available. You also use blockchain when you're interested in fault tolerance, data immutability, or censorship resistance. And we'll see a ton of use cases later which uses blockchain and has a good use case for it in one slide. And you would use decentralized database for basically when you don't really need to, you're sharing information that with parties that you trust, when you keep data confidential and when you have to handle complex and large amounts of data, because remember, Ethereum is not efficient. And you need to be able to edit the data because again, it's immutable. So you can't really go back and change your name or whatever, or any information. And if you're interested in cost effectiveness, speed, or efficiency, the centralized database is much better than a blockchain system. So blockchain is not a solution to everything. All right. Okay, so that is the end of my section. We have use cases. Oh, hi, Ayush. You're here. Would you like to share screen?
Yeah, sure, I can take over.
Okay, 1 second. So let's just take like a 1 minute break. Cool. If you have any
Can
questions,
you,
just like
can
type
you
it
ma-
on the chat. Oh, yes, of course.
Yeah, can I ask a
I
question?
think, yes.
Oh, so like you keep like mentioning that they run like the same program, like exactly who is writing or maintaining this program? Like what is like distributed? Like who is actually like making these
I can
programs?
answer that.
Yeah, Ayush, go ahead.
So when in traditional code bases, you have a maybe a company that provides a software library, like PyTorch, for example. And the people behind PyTorch will release updates to that library, and you can pip install or pip upgrade and get the upgrade. Um, the same thing kind of applies to smart contracts. The difference is that you the process for broadcasting an upgrade is much different. When you deploy a contract to the Ethereum blockchain, it's immutable and it's public. Um, so buzzwords aside, all that means is that that code is just going to live there forever. That version of the contract is going to live there forever, and people will be able to use it forever. You can't simply like revoke support for an older version of a library that you provide in a smart contract or a program you provide in a smart contract. If you want to update and maintain your code to keep track or to make changes to it, you have to deploy a new contract. and there are built-in ways in Ethereum to handle versioning. I personally actually don't know the nitty-gritty details, but you can basically broadcast the fact that it's a new version of the software, and have people use your newer version from the new contract. So I would say it is pretty similar. There are just some nuances there that sometimes you got to think about if you want to create production code for a blockchain. Yeah.
Cool. Thank you very much.
Yeah, for sure. So yeah, hey guys, sorry I couldn't join earlier. My name's Ayush. I'm co-president of Blockchain at Berkeley. I had my 162 midterm just now, so that was fun-ish. And I'm here to tell you about use cases on Ethereum. And yes, we can jump into it. So use cases. There are a bunch of use cases to kind of talk about. I tried to handpick a couple that I think highlight what the value of building on Ethereum is, building on blockchains are, but I'm happy to extend this discussion outside of the slides as long as you want. Whatever questions you have, I'm happy to answer. About me, I have experience kind of consulting for multiple companies, whether they be enterprises, blockchain startups, or your like mom and pop shops for blockchain. So after kind of trying to create multiple use cases on different platforms, these are the ones that I've picked out that I think have the most actual value of a blockchain. So let's jump in. The first class of use cases I called is just the state machine. This is a very common terminology that you'll hear all the time around blockchain world. It's that Ethereum is the global state machine. It's not really supposed to be a computer as much as it is a global state machine. So there's a multitude of use cases that erupt from that. The first way to think about it is the global state machine, Ethereum, as the backbone for virtual currency. So on Ethereum, you can basically recreate Bitcoin in 4 lines of code. That's a pitch that obviously isn't entirely true. Bitcoin has very intense optimized mechanics that make it very beautiful as an open source project, but you can offer an ERC20 token on Ethereum very easily. There are boilerplate template contracts for you to create your own coin. So if I wanted to make Ayush coin that has like maybe a cool mechanism that every time I buy a shake from Cream, I mint 1 more Ayush coin or something like that. Like I could do that on Ethereum pretty easily. So with one operation, with a couple lines of code, you can use the template, integrate. You can implement the ERC20 interface. Just fill in a couple functions, and boom, you have your own token. Obviously, the token will not be useful to anyone if you don't think about the economics and think about the utility of the token, but theoretically, it is possible to do this in 4 lines of code. Why do we create tokens? If you create an application, not like a user application, but a protocol application, like Compound, and I'll talk about this later, but you can use tokens to determine and affect the economics of the system that you've created. So keep this in mind for later. So the next use case, thinking of the public state machine, is public registry. So there are many, many examples of this, but one of them is the DNS system. If you're not familiar with how this works, right now there's basically a bunch of centralized servers and providers that do DNS lookup service for you. Yeah, so it'll map like a domain name to an IP address. This actually is very easy to implement on a blockchain because this is what Ethereum is made for. It's made to share a global state. So it's more secure on Ethereum and it's cheaper because this might not be known, but these centralized DNS providers actually do a lot of harm in terms of just basically raking money from people who want to host their own IP or their own DNS or their own domain. So there is a lot of kind of middleman corruption here that putting this stuff on a blockchain would really do good. Ethereum might not be the best blockchain for this in practice because of the slow consensus time of proof of work and the expensive consensus time of proof of work. There are other projects like Handshake Protocol that have actually gone and implemented this. So yeah. And kind of continuing down this line of thinking, as a public registry, Ethereum is very useful to basically tell you who owns what. So it can be ownership of a private document. It can be ownership of some property that relates to an official stamp on the Ethereum blockchain. Any kind of bureaucratic stuff that you can do in a normal go to the bank, go to the city hall to see who owns what, you can do on a blockchain in theory. The world still has to open up to these ideas, but in the next decade or two, this is, I think, where you'll see the biggest impact of blockchain, is these kind of basic ownership ledgers. So, yep. So an example of this that I like to point to is land titles. For example, right now, all this stuff is done on paper in basically outdated ways. There's flawed paperwork, unclear documentation. There is either a lack of central government authority, like on things like rent control. I mean, my apartment here in Berkeley is getting a rent spike of like 15%, and there's really like no governing body to protect me from that when there should be. But in terms of who actually owns the land title, if I wanted to find that out, I could go to City Hall and I could technically find out my landlord's name and see if he owns it or not. But I'll never do that because that is so tough. If I so because of that lack of transparency and just all the steps that it takes to like verify these things, I personally actually have no idea who owns this building because I will never go to check, and most people don't. So that opacity creates a lot of problems like bribes, tampering with records, and the government basically cannot be support this land record authority. So if you put it on a blockchain, there are ways to tie the technological stamp of your land to a actual physical identification of your property. And this is nothing new. I mean, you have like an ID code for your land title. Like you have like an address. You already have things that uniquely identify your property or your assets or anything like that. These are perfect examples for blockchain because you have a one-to-one mapping of a unique identifier. So why trust a bureaucratic and slow, opaque system to do that when you can simply put it on a blockchain? So this is where I see the next real use cases for blockchain popping up, especially once we have institutional adoption, once people open up to the idea of crypto economies. I think we'll start to see this in the future. So blockchains and crypto will become a really important part of personal finance in the future. That's not very exciting. That's just, I have to do my taxes. I have to also make sure I still own my house. It's nothing crazy, but conceptually it's pretty cool. I think it'll change a lot of the ways that we think about our property. So there are countries investigating this. Georgia, Ukraine, Sweden, always Eastern European countries are ahead of the curve in relation to us. So one caveat here is that blockchain is only as good as the information fed into it. So just like ML, just like any data-heavy technology, garbage in equals garbage out. So you have to trust the entry points for blockchains. You can't assume that because it's on the chain, it's trustworthy. You have to understand where the information is coming from in the first place. So that is really the main problem as to why this is not an easy fix. This is not an easy transition from our current system to a blockchain. It's because we have to create these data pipelines. And that simply will just take time because the government will, if it was easy, it would have been done already. So good. So that's kind of your basic visionary, like blockchain will allow us to own our own stuff and public ledger, public transparent ledger. And this is where governments increase the transparency. Though that's your type of use case there. kind of shifting a little bit, we can go towards use cases like microgrids. So these use cases are very interesting because they are at the infrastructure layer where you would not actually ever have to interact with the blockchain here. But the use of a blockchain can help you as the energy user. So let's go ahead and assume that we live 10 years in the future, and we have the infrastructure to be able to redistribute energy just like internet packets. And if we had a blockchain, that is basically the only way we could achieve real-time consensus on who has what flow of energy incoming to their house, who has an excess flow, who has enough, basically. If we were to rely on a centralized place for this, that would be an almost immediate attack for like a cyber attack or a grid meltdown attack, like a literal like grid shutdown attack, because that would basically be as easy as targeting one server, like one like EC2 or something, and that just is not secure. So eventually, when we start to create this kind of custom infrastructure and move towards smart cities, blockchains will be a very big part of the way that we achieve very important security guarantees about our actual underlying infrastructure. So this is another kind of category of use case. Not necessarily solving coordination failure or making things transparent and public, but actually providing provable security bounds for very important things like our energy grid. Yep. And this is kind of a thought experiment. So if you want to know more about this, just hit the chat. I can talk more about it. So those are my two use cases for kind of like things that won't really be useful to you today in 2021, but I think you should keep an eye out for in 2030. Now, moving on to things that are very cool today. The biggest and most useful blockchain use case in the next decade will be DeFi. So what is DeFi? Does anyone know? Have any of you used like DeFi protocols? So DeFi stands for Decentralized Finance, and it is essentially a thriving ecosystem of financial applications that execute in a decentralized manner. So any financial primitive that you do with your bank, with your normal stuff like lending for a loan, trading on Forex, having insurance, borrowing, borrowing. I said lending already, but any financial primitive that you can do normally, now you can do it basically on a blockchain. And why do you want to do that? Well, for one, it's much faster. Two, it's a lot more, I don't want to say liquid because that it technically is less liquid, but the markets themselves move a lot faster and are a lot more accurate predictors of what's going on in the market. So it's a lot more, the markets are a lot more transparent. So I guess that's what I mean when I say liquid, but that's not the right word. But most importantly, it's decentralized. So you won't be shut down. If you're trying to buy GameStop, Robinhood, which is a centralized trading platform who is buddy-buddy with Citadel, won't shut down your trading because the hedge funds are losing. In DeFi, it's all based on protocols. So the code will not magically make a decision to help one person or the other. It just runs in an automated fashion because there is no central person making any decisions like that. So that's DeFi. And I think this is what you'll see in the next decade as the place where the most people get onboarded into the blockchain ecosystem and the place where the most value will ultimately be created for the next couple years. So basically the big problem, as I mentioned, is that traditional finance is closed to regular users, and all these crazy derivatives and trading and all this stuff you can do are on centralized platforms that, as we've seen in the modern day, get censored. So these platforms are not built for the average person to win. They are built for hedge funds and built for institutions to win. And I think that's something that the public has more and more been aware of during COVID and during these crazy times that we've just been looking at it more. So they can manipulate markets, which they do. Retail users are literally priced out, and it gives power to the big banks. So on Ethereum, which is the core backbone for this entire ecosystem of decentralized finance, you can build out protocol applications using smart contracts that handle this financial logic. And the best part is you can go on Etherscan and actually see the very code that you are using to handle your own money. So it's a completely different paradigm than what we've ever had before. You can actually verify and debate about the protocol and the game theory and economics that are used to handle your money. So you have as much of a stake in these protocols as you want. So on the right, there's a couple logos there. On the top is Compound, which is a lending company built on Ethereum. And that is the place where that is the most stable and very well built out lending company on Ethereum. On the right, there's Uniswap, which is a very famous exchange. You can swap the tokens on Ethereum. Open is an insurance platform started by Blockchain at Berkeley members. They recently raised $3 billion for their seed round. And on the bottom there is Yearn, which is basically an aggregator of all of these functions. So what are the drawbacks of DeFi? First is that it is capital inefficient. There are high fees right now because on Ethereum, proof of work is expensive. So to trade, you actually have to pay gas fees. And the users pay gas fees. So you have to, it's basically like, right now it's more expensive than it should be. Hopefully this will be solved in the next year, honestly, because ETH2 is going to come out. Ideally, layer 2 scaling solutions will come out, which will make these gas fees reduce significantly. But until that happens, it is inefficient. There also is risk from composability in smart contracts. And for example, like if I wanted to build an application on top of Compound, I could do that. I could literally call the Compound smart contract and build on top of it. And that's very encouraged in this space. But if Compound goes down, so does my application. The benefit to this is that like there are winners here. So places like Compound and SushiSwap and Uniswap, they are actually like established enough and trusted enough that you could build on them without any worries. But there is a risk. You can't just blindly trust. You have to do your own analysis. And then front running is a major problem in the industry right now, which, to be fair, also happens in traditional markets as well. Like entire companies like Jane Street are basically built on the idea that they can front run with high frequency trading. So this isn't anything like super new, but it still is a problem in this industry too. Yes, EIP 1559. I believe that's the one about economics and the game theory of Ethereum, right? So, I will cover that maybe at the end of this lecture. Just whatever I know about that, but I honestly don't know enough about it to just sidetrack into it in a short amount of time, but I'll definitely get to it. So yeah, can you all think of any other kind of drawbacks? I think there's like one that isn't mentioned here. Learning curve is high. I think it's getting better because there's more education on these things, and the user experience has improved like a lot. So you can actually use wallets now. Like MetaMask, honestly, makes this all really easy with just a couple button clicks. You can do it, but ultimately you still have to have some idea of what's going on underneath, and it's going to take a while for the majority of the population to be able to speak that language, and that is just kind of a fact of life. We are like Yeah, we are in the Bay Area in Berkeley. We have like we're kind of on the cutting edge of things, but for the entire 8-10 billion population of the globe to like be able to be comfortable with blockchain, it'll take time. Great. So moving on. Another use case is prediction markets. So these have already kind of been put to use recently in the Trump-Biden election, 2020 election. There were actually bets placed on who would win the election. And the idea here is that this bet would be more accurate than polls. It turned out to be relatively true. Arguably, there are arguments on both sides. Prediction markets are cool because you actually have stake in the bet. So the idea is that because you're putting money down on what you think will happen, it's a lot more accurate indicator of the public opinion than simply saying yes or no on a poll from someone who you don't even want calling you in the first place. So we found that in the election, it did obviously show that Biden would win, but the polls said something like Biden was a landslide victory candidate, and the prediction market said that it was much closer than that. So the disparity is interesting to research and look at. No one has really concluded either way because you can't. It's kind of hard to prove one way or the other, but definitely interesting to look at how they're so different. And oracles report the outcome. So an oracle is basically a trusted pipeline to the outside world for a blockchain. As I said before, data in or garbage in is garbage out. So an oracle is like something that the community trusts to put good data in. And it could be centralized. A lot of the times it has to be, but there are companies that make decentralized oracles like Augur. Augur is a good company. So benefits of prediction. Oh yeah, there's a question.
Yeah, I was just curious about the prediction market. Since they're voting on what they think would happen, wouldn't that be less accurate? Because like, let's say I have a personal belief that X is going to win, but I'm feeling like pessimistic or something that like on a larger scale, people won't vote for him. So I'm not necessarily going with what I think. Like,
That's a
you
fair
know what I
point.
mean?
Yeah, I think that's honestly a question that I don't know the answer to. But the argument for prediction markets is that the bet is more accurate than the individual poll. So yeah, because I guess it reflects two different types of public sentiment. Like one is like the meta game where it's like, okay, even though I support this guy, who do I think will win ultimately? That's like a second layer of thinking versus the poll is just like, you're calling me, all right, Biden. So that's why I think potentially prediction markets could be more accurate. But I'm wondering, I really want to see like a good psychology or sociology like study on it. Like it would be really cool to read that.
Yeah, thanks.
Yeah. Cool. So yeah, I kind of said all this already, but like polls are just annoying. It's like some random CNN or it's like some company that's calling you. You don't even want to talk to them. But prediction markets are like you have to buy into it. Yeah. So you're buying oh yeah, so in a way you're buying information here. So like, will movie X flop? Will my house burn down? Is there a bug in my smart contract? So this is where you start to get really sketchy with prediction markets. It opens up since it's like decentralized and a company would never pose a question like, will Ayusha's house burn down? Like that would just like no central company would ever pose that as a question and have people bet on it. But in a crypto anarchist world, there's no rules like that of what you can bet on. So this is kind of just fair game. And this can even be taken to the point of like really nefarious things like assassinations and things like that. So it is just an interesting mindset shift to think of these things. Yeah, so I bet $1 million that Bob will be like dead October 4th or be alive on October 4th. So this could create an assassination market. And that's like kind of scary to some people. So this is another reason why crypto and blockchain are scary to many people, is because of these kind of fundamental shifts that take us away from like what we consider to be a secure, quote unquote, secure state. So this is the philosophical part of blockchain. Like, it's not just tech that you use to make your product better. It literally is representative of a fundamental shift in the way we think about society. So it's serious stuff. It's not just, it's not just for industry. Yeah, Brian, what's up?
How would you like confirm that Bob's house burned down or some real life event?
Yeah, so that's what I was mentioning before about let's see, trusted oracles. Oopsie. So yeah, here it says oracles report the outcome. So excellent question. Ultimately, whatever choice of platform you have to use, they will have some sort of trusted oracle. So a oracle could be in the form of an API that like reports to a trusted entity. An oracle could be the form of like a committee that votes on the outcome. There's ways to keep it decentralized, which these two companies do pretty well, Augur and Gnosis. So you can look into their platforms on how they do decentralized oracles. So there's like algorithms that you can do to have a committee be selected and have the committee vote, basically, and that's your oracle. And if you vote incorrectly, like you get slashed and things like that. But yeah, ultimately you have to trust an oracle, and it's up to you on how decentralized the oracle is.
Okay, cool, gotcha.
Yep. Okay, so that's pretty much my entire take. I think one thing that was said to me when I was taking this course that I never forgot was that the internet, when it was born, had no compelling use cases for the first 20 years of its existence. And only after that, we started to see widespread use of it as a part of our lives. We're only about a little over 10 to 12 years. Well, I guess specifically we're 13 years into blockchain. And I would argue real adoption is like starting now. So there is a lot of time left in this runway before blockchains could actually become useful for the average person. Once layer 2 kind of comes in and we see really low transaction fees with really high transaction speeds, it's kind of a Pandora's box of like what could be possible here. And I say Pandora's box because it relates back to that mindset shift. This will scare a lot of people. When people start using blockchains, people start holding their money in crypto, people start going bankless. These institutions that have basically governed our lives for, I mean, my whole life at least, will start to lose a little bit of the control that they had in the traditional sense. And that'll be very interesting to see in our lifetimes. So the internet has kind of done that. It used to be like that, and then it got centralized because that's the easiest way to build scalable applications nowadays, is to just centralize it and make a Facebook. And that was good then, but I think we've outgrown, as a society, we've outgrown the desire to be part of a centralized Facebook. So now we'll see what Web 3.0 looks like. And blockchains are the backbone for Web 3.0. So keep an eye out for different things you see in this space. I don't think anyone who works in the blockchain industry really knows what's going to happen, to be completely honest. There are some people who think it's going to start in gaming and start in really weird places and then go from there. There's some people who think DeFi is the answer to everything. But keep an eye out, make your own opinion, because something is coming and most people don't really know what it is. So that's my ending take for y'all. Nope. But yeah, any questions? I can answer them. Otherwise, we can wrap up. Yeah.
I have a question about the land usage portion of the presentation. I think you mentioned that you think blockchain will change how we think about land. and that'll allow us to own our own land. But if we're using blockchain as a substitute for the title ownership or the paperwork, how is that going to actually change the way we own lands?
Yeah, so I guess ultimately the question to ask when thinking of blockchain for these kind of use cases is who will run the nodes? So who will participate in maintaining the blockchain? If it's Ethereum, then it's basically anyone who ever wants to participate can be the person who tells you who owns what. If it's another blockchain, maybe like the US government creates their own like private blockchain, then there's not really that much difference. It just becomes more transparent. But at the end of the day, the government is the one who tells you who owns what. So there's really varying scales of how impactful a blockchain could be. If the government, if the US decides to put, or forget the US, if like Alameda County decides to put their land titles on Ethereum, that basically means that anyone in the world can see in Alameda County who owns which house if they wanted to. That could be good for a variety of reasons, or bad for a variety of reasons. If the U.S. government creates their own private blockchain, which they literally are thinking of doing, which also could be good or bad for a variety of reasons, then it would essentially be the same thing, except scammers and I guess malicious people like certain landlords could not rely on the vagueness of verifying this information, because tenants, which are like the users of this system, would have the explicit ability to press a couple buttons and verify that this information is correct, and basically get all the facts and stand up for themselves in a transparent way. So I think that's where the biggest benefit comes in my head, because it's not really about decentralizing, like I guess decentralizing the power to tell you that you own your land. It's more about making that publicly available in a way that it is technically right now, but not practically.
Thanks, it makes a lot of sense.
Brian, do you have a question, or you just, yeah, is your hand just up?
Oh, that was up from earlier. Sorry.
Okay, yeah. Cool. So yes, proof of stake. So ETH 2.0 is on the horizon. It's been on the horizon for many years. Unsure. The whole community is pretty unsure when it will actually be used. The developers, the Ethereum core developers, have pushed the deadline for months. But the idea behind ETH2 is that the main benefit is that it'll move to proof of stake, which I think we learned about already. Yeah, I think we did. And yeah, so the benefit of that is multi-fold. It would just be faster, it would be less expensive, better for the environment. So I definitely want it to happen. I just think it'll take longer than anyone wants. And on that note, honestly, proof of work is the only consensus mechanism that has mathematically provable bounds for its fault tolerance. Proof of stake does not. And that, I might get some shit for that, for saying that, honestly, by some ETH heads in our club, but proof of work is the most secure consensus mechanism, flat out. And that is a big reason why it's been so slow to move to proof of stake. If it was as good, it would have just been done already. But it's really hard to make it as good. So, yeah, it's definitely you all. Good. Cool. So, yeah, if that's let me know if you have any more questions, but we can definitely wrap up whenever.
The quiz is set to open at 7:30, but I can also just open it now if people want to work on it and ask us questions as you're working on it too, since lecture ended.
Should we stop the recording?